Hello guys, I'm Carlo Ayon and I'm now going to discuss all about the bisection method. So let's start. So what is bisection method? It is a root finding element by approximating a root in a midpoint. Bisection is the division of a given curve, figure, or interval into two equal parts or halves. So, a simple bisection procedure for iterative converging on a solution which is known to lie inside some of interval that lies at a b proceeds by evaluating the function in the question at the midpoint of the original interval, which is x is equals to a plus b all over 2, and testing it to see in which of the subintervals which is it is a or b. So the solution lies. The procedure is then repeated with the new interval as often as needed to locate the solution to desired accuracy. So the more interval, the more accurate we are going to find what is the true value. So for our example, we have an equation for finding the x of m, or the midpoint, which is xl, or the lower x plus xu, the upper x, all over 2. For the condition, we have if the function of xl times the function of xm is less than 0, then therefore the midpoint will replace xu. But if the xm times xu is less than 0, then therefore we're going to replace the xl to xm. So for our example, function of x is equals to x squared minus 3, which I have assumed that we have an upper x of 2 and a lower x of 1. So first we are going to find xm. So the first xm in the 0th iteration is 1.5. It's 2 plus 1 all over 2, which is going to give us 1.5. In this table, I have provided the answers in this table. So and we're going to continue. So we are going to test the results. So if fxl times xm is less than 0, then we're going to replace xu as xm. So in here, so we're going to do it in actual calculator. So fxl is negative 2 times xm, or fxm, which is negative 3/4, which has given me 1.5, which is greater than 0. So that statement is false. So next is the fxm, so negative 3/4 times the function of xu, which is 1. Since negative 0.75 is less than 0, then therefore we are going to replace xl as xm. So in here, you see our xm at the first iteration is 1.5. Index, 1.5. Then since the product of fxm and fxu is less than 0, then therefore we're going to replace the lower x as the xm. So if you're going to continue, then you are going to easily provide the information that we need in this method. So that's how basic it is to find the bisection method. So thank you and thanks for watching.